My name is Tom Reed. I am the program manager for the Energy and Manufacturing in Appalachia program. It is a program that we received some funding from a couple of different opportunities through the ARC group. And as you can see, looking at the slide here in the upper right-hand corner, we cover 156 counties across 5 states. And we are here to help small and medium-sized manufacturers to engage in energy supply chains and to find energy efficiency within their processes. So we have a lot of different resources, information, funding, and information on even more funding. What I would do would encourage you is to go to our website, wemakeithere.org/energy, and I just put that in chat. And just as a reminder, I tend to always forget this when I do an introduction, that chat is going to be a great place for you to put any of your questions that you have in there, share any information that you would like to with the group. You can do that there in chat, and that's where I do have our website to go and look. But you'll see, as we have on the slide here, we have some research, some materials, some do-it-yourself tools, and assessments to help get you started on your journey. There are other webinars and videos of some past webinars and tours coming up. I don't know if we have a tour that we're working on at an energy company in May, but I don't think we have that up yet. We should have it up next week. And then again, there are some technical assistance and mini grants. So I encourage you to take a look there and reach out to me or anyone on this, on our staff here or grouping that you've been contacted by to see ways that we can help you. But today, we're continuing our Sustainability Change Champion webinar series. We're at webinar number 3, the business case for energy audits. And I am pleased to introduce 2 folks from WB Engineers and Consultants to talk about this topic today. We have Bart Stewart, Managing Director, and Desmond Green, Managing Partner and Director of Building Optimization. So welcome, gentlemen, and looking forward to hearing you talk about energy audits.
Thank you, Tom.
Thank you, Tom, and good morning, everyone. As Tom just mentioned, this is the 3rd webinar in the Change Champion series, round 2, if you like. This follows on from Marcel and John's presentation from the University of Pittsburgh. So during this presentation, we'll be talking about energy audits that can be performed on medium-size, up to medium-size industrial manufacturing facilities. We'll discuss what energy audits are, how we perform them, and the benefits to you and your company. And we'll provide you with a business case for having an energy audit completed. Just some housekeeping matters. You can drop any questions you like in the Q&A or the chat, and then at the end of the presentation, we'll address the questions and we'll unmute the microphones. And if you have any other further questions that you think of when you hang up or in the next few days, just feel free to email myself and Bart, and we can address those directly for you. So just a question for everybody in the webinar. What are your drivers for doing energy audits? You may want to reduce operating costs for your facility. Maybe you're in a region where you have to comply with local laws or local initiatives by a certain date, or you will or comply by a certain date, or you'll be paying penalties and fines. Maybe there's a personal desire to drive change within your organization, to drive to be a more sustainable and greener organization. Maybe being demanded upstream by a client who wants its vendors to start reporting and tracking carbon emissions, especially scope 1 and 2, so that they can track their scope 3 emissions. We'll talk a little bit more about that later on. And then maybe there's a drive to improve the company's ESG ratings to reduce risk and improve opportunities for investment. By way of introduction, my name is Des Green. I'm a managing principal with WB, and I am the director of building optimization nationally. My background is mechanically, and I am a licensed engineer in New York, New Jersey, Pennsylvania, and multiple other states. I've been with WB for the past 23 years. Just a brief overview of WB. We are an MEP consulting engineering company with 200 employees across 12 offices nationally. And we have been in business for just over 25 years. We celebrated our anniversary last October. Our markets are primarily in commercial, industrial manufacturing, science and technology, and biopharma, mission critical, and data center world, and technical advisory services with EV charging. Bart, I'll let you introduce yourself.
All right. Thanks, Des. So Bart Stewart, Managing Director of our Washington, D.C. office located in Rockville, Maryland. The D.C. office is our Mid-Atlantic hub. So north-south, we're going to serve from Pennsylvania down to southern Virginia, and then anything east of the Mississippi. Where Des is our corporate thought leader on all things energy. My office would be responsible for executing the individual projects, ranging from studies, kind of what we're talking about through here, through design packages, construction oversight, and testing and commissioning. So with that, let's jump in. Des will kick us off and start talking about how much it costs to operate buildings.
Sure. So these are some of the average energy costs for operating facilities of various sizes. The data is based on average industry standards. The actual cost is going to vary by facility and will depend on the activities that are taking place in the facility. Again, these are average numbers, but we thought we'd provide them so that it kind of offers a helpful baseline while we talk about audits and the reduction in operating costs. So we just have a range of facilities here from up to 50,000 square feet, 50,000 to 100,000 square feet, and then 100,000 to 150,000 square feet. Your facility may be within that range or maybe a lot higher, but again, these are average costs so that we can kind of talk about baselines and the savings. So what is an energy audit? So an energy audit is the process of assessing the current state of a building and then making recommendations to improve its performance. So in essence, we identify the inefficiencies with existing building equipment, systems, and operations, and then develop these into energy efficiency measures, EEMs, or sometimes called energy conservation measures, kind of interchangeable, not exactly the same, but you'll hear ECM and EEM, they kind of mean the same thing. And so when these are implemented, there will be a reduction in energy usage.
So I'm going to talk a little bit about ASHRAE for a moment. You may have heard about ASHRAE energy audits. I'm going to talk about exactly what that means. So ASHRAE is the American Society of Heating, Refrigeration, and Air Conditioning Engineers. That's the trade association that, for instance, I am a member of, a lot of people in our company are a member of. And they're the kind of the governing body for all things HVAC. Many ASHRAE standards ultimately become building codes or become referenced in building codes. They also have the most widely used definition of energy audits. And the reason why ASHRAE is that governing body for energy audits is because that's really where the number one focus on energy audits is really on finding those inefficiencies in the building itself and the mechanical systems being such a heavy user of that. So I'll jump into the different levels of energy audits. So we start with the level 1 ASHRAE energy audit. This is going to be a high level audit. It's going to start with a detailed analysis of your energy use. They're going to be looking at historic data, primarily from energy bills, and we're going to use those that data to develop your energy use efficiency metric and your energy cost efficiency metric. So those are all terms that you may or may not have heard. If you're familiar with LEED, LEED talks about EUIs regularly, your energy use index. And so that's a common way of documenting your energy use per square foot of the building. So it doesn't matter what size your building is, so you can compare your energy use to the energy use of other buildings of similar types, even if they might not be the same size. So once you have that EUI, you can compare it to those other buildings and really get an idea of where you fit on the scale, which will tell you how much opportunity for improvement you have. This will also then include a walkthrough analysis looking for low cost or no cost items. And then it will lastly identify things for further study. So potential capital improvements, things like that. So where we see this applied the most is for people who have multiple buildings, either on a campus or in different regions, and they want to figure out where to put their time and money into. So you do that at level 1 analysis on all of your buildings, figure out which ones are the performing least efficiently, and that's where you're going to focus your next efforts on. So the next after that would be your level 2 audit. Many people jump right into the level 2 audit. If you only have one building or a small number of buildings, there's less benefit in doing that level 1. This will start off with a lot of the level 1 aspects. So you're still going to be calculating your energy use index and your energy cost index. But then from there, this is really going to develop a fairly comprehensive list of EEMs, the energy efficiency measures. So it'll be looking at all of your different systems, and it'll be looking at your operation and maintenance procedures as well. What this does not include is potential solutions where a lot of engineering is required. So, the best example is if your facility uses a lot of natural gas heating or natural gas boilers, and you want to look at converting that to electric, there's a lot of analysis that goes into that, particularly on the building electrical system and whether or not it can support electrification of those systems. So that higher level of analysis would not typically be included in a level 2 audit. Level 3 would include those things. So that's that big step up. So you're doing a lot more detailed analysis, both on the engineering, doing that additional study, but also on the cost wise. So in level 2, you are going to be developing cost estimates. So we would be looking at your return on investment in a level 2, and that being a simple payback of just energy savings divided by how much it costs. And then the level 3 is going to go to a much higher level of pricing. So we're going to be talking to manufacturers, but getting detailed equipment costs, doing more detailed takeoffs of equipment and piping and things like that. And that will get you to a higher precision on your ROI. So that we're looking at the number of years it will take to pay back your investment. So, we generally don't recommend you do something that's going to take 30 years to pay back. And a return on investment of 30 years is typically not a good investment because that system isn't going to last that long. So you could be potentially at a spot where you are, by the time you have to replace a system again, you still haven't paid for the initial investment. We also often, I would say most often, see the level 3 audit as a follow-up to a level 2 audit. If the level 2 has identified particular opportunities that the owner is interested in exploring further, well, we can take that level 2 and add on a level 3 for particular elements.
Thanks, Bart. Yeah, so the next section we'll talk about here is how do we actually do an energy audit? What's involved? What's our involvement? What's your involvement? And what's the output after the process is followed? So something to keep in mind before we start, which is really important while we discuss the audits, is that it is a collaborative effort with our teams and yours. The success of an audit depends on our teams working closely with your teams. And the reason for that is, you're experts on your buildings, you know how they operate, you're engineers, managers, maintenance people, they know how your building operates. They know where the skeletons are buried. They know the quirks. They know the common issues. And unless an audit team is going in and talking to your building, the audit is not going to be very useful. So it's really important that that whole team starts and finishes together. So in WB, we've developed processes that we follow for all of our services, and this allows us to issue documents of the highest quality and accuracy. So what we're looking at here is a high-level overview of an audit process. This follows the main steps of an audit outlined by ASHRAE. This is really based on the ASHRAE Level 2 audit, which Bart already described. So we'll start with benchmarking, which we get into more detail in the next few slides. We'll do the surveys, do the interviews with the building surveys. We start developing the energy efficiency measures, or the EEMs. These will include the energy reduction calculations, cost of construction, the payback, and then we'll issue a final report to you after all of that information has been put together. So the first thing that we'll do seems simple, but it's the kickoff meeting with you and your team. We're not just going to arrive at your building one day and say we're going to do an audit. We want to kick off with your team and ours, make sure everybody fully understands what the scope is, what the intent of the audit is, and just to set realistic expectations on the scope and the schedule and what the output is and what you will do with that information, because that really is going to impact the way we actually do the audit. And as I said, we start by establishing a baseline for the facility, which is called benchmarking. You're going to benchmark your data, your utility data, and you need to establish a benchmark or a baseline, because if you don't, you can't assess where you're going to go in the future or how the implementation of the energy efficiency measures is going to impact the overall energy usage for your building. So the benchmarking is really important. So we'll use utility bills, power, gas, and water to benchmark the building. And we typically use Energy Star Portfolio Manager. And if you're not familiar with Energy Star Portfolio Manager, you should take a look. If you don't have a profile, your building doesn't have a profile, you should really create a profile with them. It's fairly easy to do. You just go to energystar.gov. Then the information that you need is obviously the building address, the building area, and the various categories of usage within the building. And then you start feeding in the utility data for the gas, water, whatever else you use. And what Energy Star Portfolio Manager does, it rates your facility against your peers, against your facilities that have similar functionality and similar usage. And it also then gives you a baseline where you can start kind of establishing goals from the audit. And then we'll begin by interviewing the relevant personnel, like facility managers, operating engineers, facility staff, other people who have really good knowledge of the operation of the facility. Again, this isn't prolonged. This isn't like hours long. This is, we'll send questions ahead of time, and you'll get an idea of what the type of information that we need. But again, it's really important that we get the input from the people who know how the building operates, so the audit will be the most effective. In addition to that, it's also really important for us, or whoever's doing the audit, to understand any environmental requirements with your processes or the manufacturing, whatever else is going on in the building, so that we don't suggest something that's going to negatively impact those standards. So that's really important for us to know up front. And again, as Bart mentioned, we'll do I will analyze the historical utility data, and what this will do is this will provide important insight into the current building operations, and we may be able to spot some anomalies in the operation of the building, with maybe spikes of gas usage during the summer, or drops of electrical usage during the summer. So what that does is we start forming some intelligence before we go into the field and do some surveys, so we can actually address those while we're there. And then we'll do a complete survey of the building. This will include recording data about equipment and systems and how they operate, taking equipment inventory and photographs, and then doing a full building controls review, especially if there's a BMS. We establish how the building operates, current facilities requirements, which is a document that outlines the current specifications for a building, includes temperature, set points, relative humidity, operating hours, levels of filtration, pressurization requirements set for each space. So if you don't have a CFR, current facilities requirement, you can easily put one together, or we can do this as part of the audit. And then we'll review schedules and temperature and pressure set points. One thing I didn't mention in stage one is when we collect the existing building data, not only would we collect the utility data, but we'd look for existing documentation that you have, existing design drawings, as-built drawings, balance reports, maintenance, O&M manuals, any other records that you have that you think will help us. That they're always really helpful.
I did just want to jump on one thing, Des. You mentioned the BMS. That is a building management system, and that is particularly for the mechanical control system. So you might a simple building might just have some thermostats connected to rooftop units, but a more complicated building that's going to have systems that interact with each other, you're going to have a centralized system that talks to all of those systems and controls all of those systems. So building management system, building automation system, and energy management system are all three fairly common terms for the same thing that you may hear.
Nice segue, Bart. So, so what's unique to WB is that we have a dedicated commissioning team and a dedicated building controls team. And they work closely together with our energy audit team and engineers to analyze the building management system trends, if there is a building management system, as Bart said. Again, they'll also review the front-end graphics, if there are some, so they can highlight any potential issues that they see with devices, set points. And again, they may be able to do that ahead of a time so that we're armed with this intelligence before we go and do the survey. And then, having performed our energy analysis and the survey work, we start developing energy efficiency measures, again, with your input. We'll perform calculations to estimate the energy reductions for each energy efficiency measure. Sometimes you'll choose not to proceed with them because it just doesn't look like they're going to go anywhere. So that's fine, and we'll review those with you. So, for example, a typical EEM may be, we'll see that there's a constant volume system serving a space in your facility, which a constant volume is a fan just running at the same speed all the time. And we may look at that and may opt to review the potential of changing that constant volume system to a variable air volume system, which is a system that instead of going constant volume, it'll vary the amount of air going into a space by modifying the speed of the fan. And again, that results in significant energy reductions. And so our calculations will encompass the cost of replacing the constant volume system with the variable air volume system, the associated payback with incentives and rebates, if there are any, associated with the reduction in energy. So then we start building a full energy audit by performing these calculations for each EEM and start developing a big picture as to how these will really affect and impact positively on the energy usage in your building.
And circling back to the conversation about interviewing building personnel, if your building has clean rooms or other similar spaces that require a certain amount of air changes or air volume, you can't slow down the airflow. And that's why it's so critical for us to work with your team to understand how the building operates and what those processes are, so we don't recommend something that would actually negatively impact the operations of the building.
Yeah, so that's the process, and then the actual output of the audit is a formal report. So this formal report will have obviously table of contents, an executive summary of all the energy efficiency measures that we developed, outlining the associated energy reduction cost of construction, cost of implementation, payback, any incentives, rebates that are available, and then our recommendations as to which ones we think should be implemented and maybe in which order. And then there's a lot of, basically an audit provides you with a lot of data of your existing systems and a lot of data on what improvements you can take, or what measures you can take to improve the energy usage in your building. So all of this data in the report can be used for a number of reasons. It can be used to develop a roadmap so that you can meet the local policies or codes, so you're not paying penalties 5 years from now. It can be used to develop or to meet sustainability goals that your company has set, or can be further developed into a master plan with budgets and implementation schedules, and get really into detail into a really good master plan that can be presented and can be used by your company to reduce energy and meet all those goals in the future. So the data from the energy audit can be used really to make some really well-informed business decisions about capital investment in your facility. And then why would you want to do an energy audit, which is really the topic of this presentation? We've discussed what an energy audit is, how we do them, what the output is. The big question is, why would you want to do an energy audit? What's the business case for it? And there are a number of reasons to perform an energy audit, which we'll talk about in the next few slides. The first one, and obvious one that we've talked about repeatedly, is to reduce energy consumption and reduce operating costs within your facility. And reducing operating costs also increases the value of your asset in your facility. So doing an audit, implementing the energy efficiency measures can actually increase the value of your building and your asset. It results in, if you're implementing the energy efficiency measures, they'll improve the operational efficiency of your equipment and your systems. And then by having your systems run efficiently, the lifetime of the equipment and the systems is extended significantly. Again, extending the life of your equipment kind of reduces the amount of time over the lifetime of your facility that you have to replace it. Again, saving money. And then having all your systems and equipment running at optimal performance, they are more reliable, so there's less downtime, and they're more resilient to changes in the operation of the facility, be that a scheduled change or if you like, a mistaken change. Again, less downtime and more resiliency. Implementing the EEMs again will result in reduction in GHG emissions, and then that reduces the impact that your facility will have on the environment. And another indirect benefit is that you can market yourselves, if you like, as having sustainable and green operations and facilities, if that's maybe what your company or your executives want to promote the company. This can be used on websites, brochures, etc. And then what we're also finding ourselves in the market is that more and more clients upstream are expecting their vendors to have sustainability goals established and to be able to report on their scope 1 and 2 emissions that impacts the client's overall scope 3 emissions. And again, we'll talk about that a little bit later, and it'll also be talked, we'll discuss it more in the next webinar, webinar number 4 in a couple of weeks.
And just thinking about, you mentioned Energy Star earlier. Energy Star does give you a single score, which is very easy to understand. And that Energy Star score is a very marketable number, assuming it's good.
And then finally, similar to the marketing opportunities, having a sustainable facility and a company with established and published goals can impact the retention and attraction of new employees, some of which would like to work with a company that has sustainability goals and is, if you like, a green company.
All right. I'm going to start with a couple of frequently asked questions that we get about energy audits. The first one, of course, how much does it cost? So we got a couple examples here. Sorry about that. There we go. And it is a, there we go. So this example here is a 50,000 square foot manufacturing facility. And you can see it is a fairly wide range. You know, generally $15,000 on the low end, up to $50,000 on that higher end. And it can be higher, but that is rare. And so what drives it on that spectrum is really how complicated the building is. If you have a fairly open building with not a lot of distinct spaces, not a lot of different types of systems, you're definitely going to be on the lower end of that scale. But if you have 50 different spaces, all with different types and different usage, different environmental parameters, different systems serving those spaces, that would really push you on that higher end. So it really is much more about the complexity of the building than it is about the size of the building. So, you know, as Des describing all the steps, you can see that we have to go through all the same steps regardless of how big the building is. But the amount of time you spend developing EEMs is really going to be dependent on how many systems there are that need to be looked at and need to have calculations done and sketches and diagrams for. The next is, how long does it take? The answer is usually 3 to 4 weeks. Again, if you've got one of those much more complicated systems, you're going to be farther than that. You know, we have seen ones that take 7, 8, 12 weeks on a really big, complicated building. But really, for what we're talking about, 3 to 4 weeks is what we're looking at. And because of all of those discrete steps that all need to have different people involved in them, it is very hard to compress it to much less than 3 weeks, even in a relatively small building. Is it invasive? Not really. We are not going to be cutting holes in anything. We're not going to be drilling anything. Where it can be a little bit invasive is that we would need to have access to places. So we could be underfoot during our survey. There may be a driver to do it after hours. If our presence would require, you know, an area to be shut down, if it's a clean environment and we'd have to be doing gowning and get in the way, we might want to do that after hours. So our presence is not disruptive to the people who are working in them. But that's really all it is. It's access coordination versus cutting holes in things. And then what are the savings? What's the ROI? So just a reminder, the ROI is your return on investment. So what we're looking at is the amount of money that you have to spend divided by the amount of money that you're going to save every year. So if you have to spend $100,000 in your EEMs, you'd really want to be saving, you know, at least $15,000, $20,000 a year, so that your return on that investment, you would be getting a payback within 5 years to 7 years. The low-hanging fruit will be faster. We generally don't recommend things that are significantly higher. But we are looking at 10 to 30% in savings in the first year. Des, you want to speak a little more about that?
Yeah, so yeah, on average, the potential savings from an audit on a facility that hasn't been audited or recommissioned in a number of years is 10 to 30%, and that's after the implementation of the measures and rent commissioning. And I mentioned rent commission because that's one of the low-cost, high-impact EEMs that we'll actually recommend. And rent commissioning alone will result in 10 to 50% savings in the first year with a less than 1 year payback for investing in doing that retrocommissioning. So it is significant. There's significant savings, especially in the first year, but all the other things that we talked about in terms of operational efficiency, resiliency, dependability on the equipment, and the extension of the equipment life, all impacts, is all addition to that 10 to 30% savings. So it's a really effective way of reducing operating costs and all the other positives that it brings to your systems.
And for those of you guys who have never heard the term retro commissioning, what that refers to is, I described the mechanical controls, and that's an integrated system. Over the years, things will kind of go out of calibration. People mess with sequences. People disable things. A little tweak here, a little tweak here, a little tweak here. And now, 5-10 years later, the system does not work the way that it was intended to. So retro commissioning is that process of going back in and fine tuning that system and really just bringing it back to the way it was always intended to operate. And what we have found consistently, as this spoke to, is massive savings just in getting the system back to operating the way it was originally intended to operate. How do we pay for it, Des?
That's an easy question. The answer is difficult. So some of the energy efficiency measures that we identify along the way in the process may require significant capital investments to implement, but the payback and the positives that it brings to your system and your facility may implore you to do it. So there are a number of ways to finance the work, which we'll discuss here. First are the utility incentives and rebates. So a lot, if not most, of the utility companies around the country have programs that will offer a cost share for energy reducing initiatives by a client. So we'll try and capture those in our report and in our calculations. So that'll be part of the data output. And so the utilities will cover, they may cover, like if there's what we've seen before is replacing a steam absorber that may have cost, converting it to an electric chiller, that may cost, the construction costs were 1.1 million. We actually got $350,000 from the utility to cover part of that cost because we were reducing energy throughout the whole system. So it can be really generous. If you're doing, what we do recommend, if you're not doing an audit and you are thinking about doing replacement, or you're being forced to do replacement because your equipment is coming up to its end of use of life, you could call us. We could also call the utility company really early on. What we found is that the utility companies are really open to talking to you about giving you money to do this work. And the reason for that is, if they don't give you the money this year, next year's budget will be less. So what they don't spend this year, they don't get next year. So it's really behooves them to work with you to identify and get you those incentives and rebates. Some of them can be really, really generous, and they can go a long way to help you not spend as much capital as you normally would.
Now, if anybody was wondering, why would a utility want to pay you to use less of their product? It is actually in their own self-interests, because our energy usage is continuing to go up. And if you can reduce your energy and it slows that curve, they don't need to build another power plant. So any money that they spend in reducing consumption means that they don't have to build another power plant in 5 years. And in that earlier case, I think that was a jurisdiction that really wants to use less steam. So they have strong financial incentives to get people off of their steam system so that they don't have to maintain it and use it anymore.
Correct. And then typically the utilities, the incentives and rebates are divided into prescriptive and customized categories. So if you go into your local utility and you find incentives and rebates, typically they'll have a few pages of the prescriptive rebates that you can get, for example, installing a variable frequency drive on an existing motor that might give you something like $50 or $75 per horsepower of the motor, or a dollar amount per fluorescent fixture replaced by an LED. And those prescriptive options are typically unitary, so they'll give you a certain amount of dollars for a unit of whatever you're going to install. The customized measures or categories typically require some additional scope to be performed by your consultant. So maybe an energy model will be required, let's say, for completely replacing an existing building management system or a large HVAC system. The utility may, if they're providing you with the cost share, they may require you to do an energy model to prove those savings, and they might give you something like $0.05 a kilowatt hour that you save. And again, a lot of the time you have to meter that before and after, so you really have to prove the savings. But those customized incentives and rebates can be extremely generous, and very worthwhile looking into. So again, if you're thinking about doing anything to your building, talk to your utility company and I'll give you an idea of what they can do for you. Another way of not exactly financing the actual capital expenditure, but actually covering it under a tax deduction, is utilizing the tax deductions through section 179 and 179D of the tax code. These can be really generous again, but they most likely need an energy model be run on the systems to prove that certain energy standards and requirements before and after the implementation were accomplished in the project. And again, some of those can be really, really generous, and can be done proactively. You can get up to a $1.50 a square foot back, and that's a deduction on your tax, not money handed back to you. But in a roundabout way it is, but you don't get cash in hand. Also, there are CPACE programs. CPACE programs are low interest loans over long term for sustainable projects only. So if you have a couple of sustainable projects and you're looking to finance it, you can also look at CPACE. They're low interest long term.
And there are lots of weird things with the tax deductions. I think if you're owned by a real estate investment trust, I don't think those are eligible for those same types of tax deductions.
Yes, yeah, we would, if we were looking at that, we get an accounting company in to work with us on those. There are restrictions, and there are some certain types of organizations or formations of companies that you can't take the tax deductions. You're correct. But we'd work with, we're not financial experts, we're not accountants, and wouldn't pretend to be. So we'd employ accountants to help us out on that.
Yeah, my wife does our taxes.
Okay, I don't. And then just to add to this as well, a lot of the utilities and some other organizations outside utilities, like state bodies, NYSERDA and National Grid, they may do a cost share for the actual audit. So if you want to do an audit, and let's say the audit is $50,000, if you go, we can apply for you. You go through the utility or the other state body, you may get a 50% share or 75%, or some of them do 100% cover the cost of the actual audit. So just to get that audit, get that data, may cost you nothing or a lot less than you think it would. So it's certainly worthwhile to keep that in mind as well.
And the numbers that I shared earlier, that $15,000 to $50,000, that's before any cost sharing opportunity.
Yes. Yeah. So just before we leave today, there are, there's a few no cost measures that you can implement immediately or look at implementing immediately to reduce energy. And some of these are kind of basic, you probably know them before, but replacing fluorescent light fixtures with LED, installing proper lighting controls like occupancy sensors, vacancy sensors, or actual time clocks so that you can adjust the schedule so that the lights don't go on or don't stay on 24/7. And they will have an impact on your energy usage, a positive impact, so they reduce energy. You may not know, it's a good question to ask. if when you leave in the evening on a Friday, are all the lights off? Do any of them need to be on, or do you know if they're all off? And maybe if they're not, then you may look at using lighting control or some other time clock, so you can control that. Fixed devices and sensors. Again, that goes back to the retrocommissioning that Bart talked about. You fix, replace, or repair existing devices that you identify not working or not working. You may have them in your maintenance logs. You haven't got around to them yet. We highly recommend that you do that, because things like steam traps, if they're leaking by, can cost an awful lot of money. Motorized dampers, valve actuators, sensors. If you know that they're not working or they should be recalibrated, fix them, recalibrate them, or replace them. And so again, this gets into the topic of retrocommissioning. We could have and may have a completely separate presentation about retrocommissioning and the benefits, because there are huge benefits of retrocommissioning. And again, retrocommissioning is the process of fine-tuning a building system to ensure that the building is running at its optimal performance, get it back to the way it was designed to run, and then you can start making improvements.
Doug, think about the cost of operating the facility. If we're talking about a 50,000 square foot building.
Mm-hmm.
If you've got old fluorescent lights running at 2 watts a square foot and they don't turn off, you could potentially be looking at close to $1 million a year just in having
Mm-hmm.
those lights running. So you put in LEDs and then you don't run them off all the time, and all of a sudden I just saved $750,000 a year.
Absolutely. Yep. There's other ones as well. This one here, review set points and schedules. This is always an interesting one. You may have parts of your facility, be that off the part of the office space or part of your floor, where you get a lot of complaints, and the complaints are it's too hot in the summer, and so you satisfy 20 maybe 5,000 square foot of your space by running the rest of your space really cold. So you got to look at set points, balancing your HVAC systems, look at schedules. Do you have fans running 24/7 that don't have to run 24/7? Do you have HVAC systems that are running 16 hours a day that can run 10 hours a day? All of these kind of little, they seem insignificant, but they really add up and have a huge impact to your operating costs at the end of the year. So before you get into the audits, if you want, just go on a Monday morning and take a look at what you can do in terms of adjusting set point schedules. You can, we always encourage, you can, for want of a better phrase, you can experiment with your building. I wouldn't recommend that you do it on the hottest or the coldest day of the year, maybe a shoulder season like around now. See what happens when you change set points. What happens if you instead of starting a fan or an HVAC system at 6 o'clock in the morning, maybe you start at 7 o'clock in the morning. How does that impact the operation of your building? If everybody's satisfied and it satisfies your systems, you've saved 2 hours of operation a day, or over a week. It's 40 hours a month, which is significant.
Yeah, the other one that I see all the time is, you got, your big space that's maintained at 72 degrees, and then you go into the server room and it's 65. And, it's freezing. Now you got that system who's now trying to cool the entire building. Every time the door opens, you get that brush of 72-degree air that it now is trying to cool down. And if you ask your IT guys, the answer is, I don't know, that's how it's always been. The industry doesn't recommend that anymore. ASHRAE doesn't recommend that anymore.
No.
The equipment manufacturers, you ask Dell, Dell's not going to tell you maintain the servers at 65 degrees. They're going to tell you maintain the servers somewhere between 70 and 80 degrees. So raising that up so that it just matches what the rest of your space is doing, and then you don't have those systems trying to fight each other. Have this system in cooling while this system's in heating. And you can get a lot of return just by hitting up on that thermostat a couple times. All right.
Okay. The additional benefits. So bottom line is energy audits result in reduction in operating costs and an increase in the value of your asset, facility, campus, buildings, whatever that is. The added benefits, again, we touched on this briefly, are that you can market your sustainability practices to your customers. So once you get the data from the audit, you can decide, you know what, we're going to implement EEMs 1, 3, 7, and 10 by next year, and this is going to be the result. You can publish that on your website if you like, or your brochure, and you can stand by that because you have the data and you have that issued goal. And you don't have to be necessarily LEED certified or some other certification. You can market that to your clients. Say, look, this is real time. This is real data. We can do this, and these are our goals. We're using all this data to get to our sustainability goals. Again, we talked about scope 1, 2, and 3 emissions. We're going to talk about this in more detail in the next webinar, but just to explain briefly what scope 1, 2, and 3 emissions are. Scope 1 and 2 emissions are commonly known as operational carbon emissions. Scope 1 emissions are emissions from the fossil fuels burnt on site, be that a boiler, a generator, something else that's controlled by the actual building on site. Scope 2 emissions, again, operational emissions that are from your purchase of energy from the utilities, electricity, steam, gas. These are the emissions that are generated by the utility back in the plant. And then scope 3 emissions, commonly known as embodied carbon. These are emissions from the lifetime of the material, from the carbon emissions from the mining of the material to transport to the factory, to the manufacturer, manufacturing it, transporting it from the factory to the site, emissions for installing it, and then emissions from actually demolishing and recycling it. All of that are embodied carbon, sometimes called cradle to grave. And that is the value chain carbon emissions that vendors are looking to report more and more. So more of the companies that we work with, probably more of the companies that you're working are looking for you to report scope 1 and 2 emissions, so that in turn they can report more accurately in their scope 3 emissions, which directly impacts their ESG ratings and reporting. So we'll get into more detail about scope 1, 2, and 3 emissions in the next webinar.
Yeah, you don't have to have that memorized. We'll talk about it a little lot more.
Yeah.
That's
so
it.
That concludes our presentation. If there's any questions, or we can open up to any questions.
Let's see, what do we have?
Doesn't look like there are any, but if you do think of one, which typically I do as soon as I hang up, our email addresses are here. Or if you want to ask us about energy audits, or maybe some advice what you want to do, or you want us to talk to you about getting in and doing an audit for you, just email us and we'd be more than happy to have a conversation with you.
All right.
Bart and Des, that's great. It's great information. And, hopefully folks are thinking about getting that energy audit. I just wanted to remind everyone that if they are in one of the 156 counties of the EMA region, they could be eligible for a mini grant that could put $10,000 towards up to half of the cost of an assessment that is done. And I know that WB Engineers is one of the accepted auditors on behalf of the DOE ITAC program. So that would also could make you eligible to apply for some ITAC grant funds as well. So just kind of wanted to point that out. Not only all of the great stuff you all were talking about, but there are a couple of other ways that maybe you can benefit financially from it.
Thanks, Tom. Yeah, forgot to mention that.
Yeah. And one last thing too, I sometimes will give some homework when I speak, and I would just say, in addition to start planning your energy audit, and of course on the 25th you're going to hear some more, but in the meantime, if you want to start, what could you do kind of on your own? We do have an energy efficient factory toolkit that we have created, and I'm going to put that in the chat as well, or you can go to our website. There's a great way to to kind of walk through yourself and kind of set a baseline as to where your company is, and maybe start putting some information together. I think that could be a great way to get started. And then when you bring in the experts who can kind of walk through and take you to the next level, it'll be a great place for you to see how you've improved.
Awesome.
Yep.
Thanks, Tom.
Yeah. Yeah, thank you both. This was great information.